Jain, Secretary Sri Hemant Dalkar, Treasurer Mrs. Nangaonkar, from Ultratech Mr. YTTV Prasad, Zonal Head Technical, all registered ISSE members, all engineering fraternity who are attending this program from various places, and Team Ultratech. I thank you each and everyone for being virtually present here on Zoom with us today again. Due to the IT issues, we could not complete the meeting last time. With you all, I pray to God and prepare ourselves to fight COVID-19 challenges and emerge victorious. On behalf of Indian Society of Structural Engineers and Tech Cement Limited, we welcome you to the Zoom meeting on technical talk on interpretation of NDT result.
Masanji, your screen needs to be turned on.
Yeah, I will share your screen, sir.
No, you're presently probably you have shared my screen.
No, it's my screen only. Let me take this privilege to introduce our today's speaker, Mr. Ravi Ranade. Mr. Ranade is a renowned consulting engineer having vast experience on NDT and has worked on many national and international projects. Mr. Ranade is also a great trainer and has conducted large number of training programs. He has trained more than 3,000 construction professionals, which includes civil engineers, structural engineers, architects, contractors, corporate executives, and government officers. Before I hand over the screen to Mr. Ranade, few important notes which I would like to share with you all. We will take question session in last 10 to 12 minutes time at the end of this session. My request to all of you is to kindly mention your questions in the chat box. Also, this program is getting recorded and will be the link will be shared with on the ISSE website for further viewing. Our request to all of you is not to scribble on this screen as it affects the visibility and it doesn't choose to a question. You may give your feedback post program by rating the program on 1 to 5 scale. 5 is excellent and 1 is poor. With this note, now I will hand over the forum to our speaker, Mr. Ravi Ranade.
Okay, hello, welcome you. Can everybody see me? Okay, I will straightway start with my presentation. Welcome and good afternoon, everyone. Hope today we don't face any technical issues. Today I'm going to discuss mainly on the interpretation of non-destructive testing results. Basically, why to have this session? I'm practicing in this field for more than 33 years and as a auditor and NDT consultant. And sometimes we get some responses from our clients or consultants that they have some issues with interpretation of NDT results. Either they doubt, in fact, the total reliability of NDT itself. So that's why I thought that we need to have some interaction with all the technocrats. And that's why today we are here to discuss more on interpretation of NDT results. So when we think of going for any structural evaluation or NDT, normally we should go in stage-wise manner. In first we should establish what are our aims and what is information required. Then we should have document survey, maybe collection of architectural drawing, RCC drawings. If the project is new, then maybe study of your testing reports, that is a mixed design report or maybe a cube testing report. Then first we should have a preliminary visit to site. And during this site, we should collect what are the issues at site. We should collect some basic information. And then we should decide that what next action we need to plan. Probably the next action will involve a detailed structural audit. In detailed structural audit, definitely we are going to have a clinical observation of the entire structure Normally, we know that in medical practice, the doctors, they follow a very systematic path. At first, they will do the clinical observation. Before that, if the patient they know, then they will study his entire history. Then they will carry out the clinical observation. Then they may suggest for some pathological test, and depending upon this pathological test and clinical observation, if they find that some further investigation is required, then they may go for some detailed investigations like MRI or CT scan. And once all the data is concluded, then they will conclude that what is the problem, and they will do the root cause analysis and diagnose the problem, and then they will ultimately give a solution, tablet or whatever surgery if the patient wants. So exactly on same line in civil industry also we follow same line. So first we go with a documentation survey. Second is followed by structural audit. That is nothing but a clinical survey. After we carry out a clinical survey, that is structural audit, then we need to decide that which type of test, ND test, maybe it could be ND test or it could be some partially destructive test or it could be some even lab test also. So we need to decide what type of test we are going to carry out. At this stage itself, we need to agree on what test we are going to carry out, how we are going to carry out, where we are going to carry out, and ultimately what is going to be the acceptance criteria. So at this stage itself, the person who has taken initiative, he may be a client or he may be a structural designer. So he will have to involve all the concerned parties involved in this entire process, again, including owner, client, structural designer, architect, project management consultant, contractor, and of course the agency who is going to carry out the non-destructive test. So once we decide chalk out this program, then we should go with a preliminary entity. Normally, preliminary entity should cover around 15 to 25% of members. And of course, it should have some minimum core tests, maybe around say 3 to 6 core samples you can include in your preliminary entity. And once we get this data, then again we do some preliminary analysis. A structural consultant may run his say reverse analysis, and then based on that he may arrive at some interpretation. And then if the preliminary entity program, it indicates that yes, there is an issue and the concrete or that structure needs to be investigated in depth, then in such case, then we should go with the third stage, that is a detailed and specific entity. So when I'm calling a detailed entity, so under detailed entity, we are expecting that we are going to have almost a thorough inspection. It may have right from say around 25 to 100% of testing of elements. Or maybe some cases we have a very specific entity or some specific locations we need to go for a detailed investigation. At this stage, it's very important that we include sufficient core test samples. The inclusion of this core test sample is very, very important in this entire entity process. When we call that as a non-destructive test, though the core is a partially destructive test, but most of the time that is part and parcel of non-destructive test. So core test should be considered as a mandatory test when we go with a detailed investigation. Then side by side, we may go for load testing, mainly of flexural members. When we get all these data right from structural audit, study of drawings, NDT results, then probably the structural engineer, he will take this as an input in his reverse engineering, and then he will input all these data and he will come out with the issues or problem with the structure. And based on that, a root cause analysis will be done, and then a final recommendation that what needs to be done, that will be decided, and then the further action will be taken. Many times, as I said, that people ask us that what is the reliability of ND test? Many times this question is being asked. If you ask me that what is the total reliability of NDT, maybe we can say it can have an accuracy of around say 10 to 25%. But when I'm saying 10 to 25%, it means that it is assumed in this stage that you are carrying out a very systematic NDT survey, or maybe NDE, what we call non-destructive examination, which includes NDT. So herein we have properly identified the problem, we have properly identified the test, then the test agency, he has done that entire NDT program in a very systematic and professional manner. Then he has collected a lot of data from site which affect the NDT test results. We have sufficient test sample available with us. So if we have done everything in a very precise manner, then we can say that the accuracy of these NDT results will be around, say, plus minus 10 to 25%. And if something goes wrong, or if the sampling size is very less, we have not identified the correct test and we are selected wrong test at wrong location, we have not taken the sufficient data from site which affect these test results, and we have not applied the correction factors for these environmental conditions or other conditions, or maybe the test itself is not properly carried out at all. In that case, this accuracy can go even plus minus as high as 50%. So the bottom line is, when I'm saying 20 to 25%, it's very important that you're carrying out this entire process very systematically and very methodically. Now coming to when we say, suppose if I'm saying accuracy is plus minus 25%, so that means it may happen that a M25 concrete may be called as M20 or it may be called as M30. So in such case, I have seen that some clients or consultant, they ask me that if you're going to call M25 concrete as M20 or M30, then what's the use of NDT? ये तो बकवास है, इसमें तो कुछ फायदा नहीं है अगर एक ग्रेड आप नीचे ऊपर बोलने वाले हैं, then there is no point why you should go with the NDT. Then I always tell all these friends that remember that we are dealing with a very, very complex and heterogeneous material which is called as a concrete. In all rest of engineering branches, you take metallurgy, mechanical, electrical, or anywhere where NDT is being carried out, they are dealing with a homogeneous material like metals or maybe polymers, where they have a very specific properties. And in such cases, the accuracy of results, it could be even in single digit. So in mechanical industry, they may talk of accuracy of maybe 2 to 5%, but in civil industry, remember that this is not at all possible, because the material what we are dealing is having a terrible heterogeneity and it's a very, very complex. Now my question is, when we say that NDT is having plus minus of accuracy of say 10 to 25%, then I ask many times people that do you believe that your cube strength are accurate? Do we say that the cube strength what are the cubes we have tested, they have plus minus reliability of less than 10%? And the answer is straightway no. As I'm saying, the $1 million question is, does a cube strength truly represents the in situ concrete strength? I've been practicing in this field for more than 33 years, and if you really ask me, can anyone find out the exact in situ, say, intrinsic strength of concrete? If you ask me, I will give you answer that no, it's not possible. No one can find out a very accurate intrinsic in situ strength of concrete. What we are trying to go to a very near about figure. And even when we are talking of cube, remember cube are casted in very idealistic condition and they don't represent your in situ strength. The cube results are normally what we say when we test the cubes with all idealistic condition and with very specific norms, then whatever the strength that we get, that normally is called as a potential strength or the probable strength what a concrete can have at site. And normally this cube test is mainly used as a basis of quality control of concrete and not to identify the exact strength. This test is not intended for determining the in-place strength of concrete, because it makes no allowance for effect of like placing, compaction, curing. We know at site many parameters are not matching with the cube casting and testing procedure. So it is not possible that the cube results will give you a reliable value of your site. So, can I request everyone to mute their mics? I'm getting
please everyone mute their mic. Sir, please continue.
Yeah, okay. Sometimes we follow a system that to get some reliable strength of site concrete, sometimes these cubes are placed over the slab. And as the slab or beam is cured, similarly, these cube molds which are placed over slab, they are cured and then they are tested. And then people expect that in such condition where curing condition is simulated very near about to site, then we should get a in situ strength of concrete. Indian code doesn't support this, but there is a ASTM which is C31, which specifies a similar test procedure for testing cylinders. But still remember, when we are simulating this condition, under this condition we are simulating only a curing condition. But the bleeding, compaction, consolidation, curing is totally different than that of cube and that of your site concrete. So still, even if you place the concrete cubes on the slab, still that is not going to reflect the in situ strength. So that is going to give you some near about idea of what could be a probable strength of that concrete. Now we will see some of the parameters on which the cube strength is dependent. Actually, this is a very vast topic. I am not going to go in detail. If anyone is interested, at the end of my this presentation, I will show you my email IDs and my website address. If you're interested, maybe you can log into my website and you can find a detailed paper over there which talks of the reliability of cube strength results. Probably next week, Indian Concrete Institute is probably going to have a webinar on this testing of concrete. I'll be deleting the lecture on this cube test. So just I'll mention over here, I'm not going in detail because it will take a lot of time. So it is dependent on age, it is depending upon the size of cube, it is depending upon the shape of the sample, whether it's a cube or cylinder. Even it matters what kind of mold material you have, whether it is a cast iron mold or a timber or a PVC mold. It depends on number of compaction, number of blows, number of layer, compaction height, or diameter of rod. Then very important is curing temperature. Your curing tank should have 87 degrees plus or minus. Nowhere in India except few labs, nowhere at site we have this curing temperature control. Then curing period, 28 days for cubes, and normally curing is done for 28 days for cube, that is in laboratory, but at site the code recommends you to do a curing for 10 days for OPC and 15 days for blended cement. And I have an observation that I hardly see at any site that curing is being carried out systematically. The way, the speed with which presently we are doing all construction concrete, hardly within a span of 8 to 10 days we are going with the next slab. It's impossible to follow a methodical thing. Hardly, maybe 1 or 2 days max site concrete is cured. And that is the most important, that your site concrete is bound to have a lower strength as compared to your cube strength. The moisture condition is very important. The cube has to be tested in saturated surface dry. Again, I am very specifically making a statement. Hardly any labs or any sites I see that the cubes are tested in saturated surface dry condition. Most of the time they are tested in dry condition. Then another important is compression testing machine. It should be a rocker roller plate. Many times we see at site we use the hand operated machines, which are not at all recommended. Then another factor is direction of casting and direction of testing. And most important factor is the rate of loading. The IS code specifies 140 kg per centimeter square per minute is the rate of loading. But actually, we have done a lot of R&D on this, and we have seen that this speed in reality, it goes as high as 500 to 1500 kg per centimeter square minute. And if you have such a high speed, then your cube strength is going to be as high as 30 to 55% higher strength. So simply we collect 2 or 3 factors out of this 11 factors. You will notice that cube results may vary even of the tune of around say 30 to 80, 90%. And these results are not minus. Most of them, these factors are on plus side. So out of these 11 factors, even 3-4 factors, there could be a possibility that your cube results are going to be high, even up to a tune of say 20 to 50%. If this is the case, then how we believed in cube? Unfortunately, all our contract documents or tenders, they specify acceptance criteria as only and only 28 days cube strength. I think this needs to be changed. Cube test, as I'm repeatedly saying, it is not going to give you an indication of site strength. That is an indicative only strength. So we must include non-destructive testing as a mandatory testing along with cube testing in all the contracts and tenders and documents. And the most vitally important question, does the cube really fail in pure axial compression? A big question mark. So once we decide, as I said, that now we are going ahead with the testing and we are going ahead with non-destructive testing, then it is desirable that all the concerned parties, they should sit together, and before we check out even a NDT program, we should sit together and decide right from which tests are to be carried out, how many tests are to be carried out, what is going to be acceptance criteria, then what are going to be limitations at site, and ultimately what we are going to conclude from this test results. That needs to be decided before we start with any NDT program. Most of the times in India, I see that NDT program is chalked out very casually, and normally if there is some problem with cube, then somebody will say, test kar do, ek 4-5 column test kar do, ek 2-3 jagah pe test kar do. And sometimes I see that people recommend only a test like a rebound hammer, which is a totally unreliable method. A standalone rebound hammer test method should not be recommended at all. I'll come back to all this. Remember that NDT is not the only diagnostic tool. As I said, that it has to be a total comprehensive NDE, non-destructive examination program. So in that, NDT is one of the tools. Structural audit, reanalysis, laboratory testing, all they comprise of entire analysis. And NDT is one of the tools. And that's why NDT results are not the only final values, and they should not be taken as the only mathematical values. And of course, if NDT we are saying it's not a final value, nor the cube strength result should be taken as final. I see that many times in India, cube strength is overemphasized. We believe only on cube strength, and we take decisions of all these site concrete, whether the cube has passed or not. And even I see that there are many issues what to call as a cube pass. If you get a M20, if you have suppose M20 concrete, and if the cube passes, or if the cube is crushed at say 2.5, then I see that most of the time, 90% of the time, people accept that cube. And that cube concrete is declared as accepted because simply it has crossed a figure of 20. So there are many issues even with the acceptance of cube also. Actually, if we truly see that when we are talking of non-destructive tests, there are n number of methods available in market. Maybe around say 20 to 30 different test procedures are available. Out of that, only one test is going to give you the actual in situ compressive strength, and that is the only core test. No other ND test is going to give you, the direct in situ compressive strength. They are indirect measurement of the compressive strength. If you take an example of say rebound hammer is going to give you a surface hardness. If you see ultrasonic pulse velocity, ultrasonic pulse velocity is going to deal with Poisson's ratio of concrete, Young's modulus of concrete, and density of concrete. So like that, every test is going to deal with some parameter, and no other test than core actually gives you the in situ compressive strength. We are measuring some different parameter, and that different parameter is correlated to the compressive strength by plotting some graphs over there. And then you convert that, say, rebound number into a compressive strength or a velocity into a compressive strength. Sometimes I have seen that at site, when an NDT report is released, and suppose the NDT report says that there is an issue with the concrete, and instead of say M20, the results are showing as M15. Then sometimes I see that people make very loose comments just looking at the smooth finish of concrete. आपका जो concrete का surface है, that is smooth, then people make a loose comment that at site there is no issue. The concrete seems to be very sound. There is no honeycombing. It's perfectly smooth, flat, and that's why how the Q results or NDT results they are showing on lower side. The surface finish has nothing to do with your strength of material. In fact, most of the time, the smooth finish you will get simply because you have a higher water cement ratio and higher sand content. In fact, that is an indication. If you have more smooth finish of concrete, then most probably your concrete is going to have a higher water cement ratio and higher sand content. Same way, if at site, suppose you have a honeycomb finish, and the NDT results or say ultrasonic velocity is going to give you a higher velocity, then sometimes people get confused that how come that at site I see a honeycombing at surface, but still my ultrasonic is showing a very high velocity. Again, the honeycombing, what you see at site, it may be only surface honeycombing. If a concrete is very sound inside or inner core, then ultrasonic is going to give you a very high velocity. And that result is more reliable than your visual observation. So I would request not to depend on the visual observations like a smooth finish or honeycombing. Many times I see that people, after getting these NDT results, again I'm giving example, suppose the concrete is M30 and NDT results is showing somewhere as M20. Then I see that many people, they go on site with normal hammer, and then they will try to tap the concrete, and with the ringing sound, they will declare that concrete is best, good. The ringing sound, yes, no doubt, it's a very preliminary method you should use, but that is not going to give you the strength parameter. The ringing sound of your M15 concrete and M60 concrete is same. Maybe you can differentiate between M5 concrete and M20 concrete with a normal hammering, with a normal ringing sound. So ringing sound is not at all a parameter to decide whether the strength is acceptable. What is more important is correct understanding, interpretation, and correlation of all data, that is whatever we have, that is lab results, NDT results, visual observations, assumptions versus reality, then structural behavior, even construction practices, what we have followed. I will cite one example over here. We should know when we go at site for NDT, even the NDT consultant, he should collect all these data, that how the concrete is mixed, whether it is weigh batch or whether it is volume batch, what kind of site control at site they have, then what are the construction practices which are being followed, then how a concrete mix design is being really corrected, whether the moisture absorption are really corrected at site, or simply they are blindly following the mix design, which is normally 95% cases. I see that people blindly use the concrete mix designs. They never apply any moisture and absorption correction at site. Same mix design which has been given at the day one, that is used till the end of your project. It is totally wrong practice. To be frank, every day you require a fresh recipe for your mix design. So all all this data actually that is going to give you a reliability of your site concrete. So all these data needs to be collected, correlated, and a final conclusion needs to be drawn on the interpretation of these NDT results. In visual observations, again, I'm not going in detail, but in visual observation, we need to inspect all these issues at site. Now coming back to the, again, NDT results, the accuracy and reliability of NDT, it mainly depends on proper selection of NDT test. It becomes very important that which test you are selecting over here. Just to give an example, suppose you're testing a machine foundation or a turbine foundation, which is having a size of around say 10 meter by 8 meter by say 5 meters. And if we recommend over there rebound hammer as a test, I think something is going wrong. The rebound hammer, which is having a limitation of scanning only of around say 25 to 40 mm surface concrete. This is not a test to be recommended on a very solid or very thick members. This test may be useful for say members like slab, columns or beam, but it is not recommended for foundations. So as I was saying that before we start this entire NDT program, we need to have a detailed, thorough dialogue and chalk out a detailed program, select a proper test, then proper surface preparation for every test is very, very important, very important. I see that many times people don't even open the plaster. They simply conduct the rebound hammer test and ultrasonic test or even half cell potential test on the plastered surface. It's going to 100% going to give you a wrong result. And then your interpretation is going to go haywire. It's not going to match your reality. So it becomes very important that every test, it has to have a proper surface preparation, which has been given in various standards. The most important is that you should combine various ND tests. It is strongly recommended that you should not use only one test, maybe only one rebound hammer standalone test, or only a ultrasonic test, or maybe a half cell potential test. We must combine, say, 3 or 4 tests together. I'm going to come back to come afterwards on that point. Then sampling and extent of testing. It's very clear that if the sampling size, if the sampling is wrongly done and the extent of testing is very less, then again your reliability of ND testing is not going to correct. Again, on all these points, I'm going to deal in depth in later slides. So sampling and extent of testing is also important. Most important is correlation of ND test with the standard site samples. Suppose you have cubes at site. So I would recommend that if you're going to use say a rebound hammer and ultrasonic test at site, so ask your client that if he has got the cube which are not yet tested or which are due for testing, or many times it happens that at site the cubes are they are casted in more numbers, and normally out of that only few cubes are tested and few cubes are still available. So then we need to correlate these site samples. It's very important because all ND tests, the reliability and accuracy will go on increasing as you collect more and more data and you remove all the issues in that and correlate with the site concrete. So it becomes very important, and that's why you should correlate even the cubes available if this is a new site. If it is an old site, of course, nothing will be available. Then cognizance of various factors and site conditions which affect the test. Every ND test is going to have some or other factor which affect that test. That factor may be affecting while the test itself is being carried out, or that factor may affect when you correlate that with the compressive strength. So you need to collect all data in very minute detail for each and every test. And before you collect that data, you should know that what are the factors which are affecting each and every test. And your site result sheet, it should include this data. Then you should collect all site conditions, then accuracy and reliability of available correlation, say maybe between pulse velocity and strength, because every lab is going to have their own developed correlation charts. Because till date there is no standard available which gives you a straightaway correlations of say pulse velocity with strength or rebound for that matter with strength. Sometimes I see that the rebound hammer, the graphs are pasted on the rebound hammers. And in many cases, people use these graphs very blindly. If you ask me, the graphs which are pasted, correlation graphs pasted on the rebound hammer, they should not be treated as correct. Every lab has to develop their own calibration charts, and you should correlate your all these results with actual site concrete. Normally, we have a practice whenever we purchase a rebound hammer, first thing what we do is we remove that sticker on rebound hammer, which gives that correlation, and we throw that sticker in dustbin. It should not be used at all. It's only guideline because that graph has been prepared somewhere in Switzerland way back in 1960, and blindly that graph is being followed everywhere. Then always, it's not that only NDT. When we are going to carry out NDT, we need to study the history of structure. Because if I am going to conduct a half cell potential, then I should know that what kind of repairs in past they have been carried out, whether the steel has been already protected with anti-corrosive treatment, and now I am conducting the test on this structure. So if this data is not available, if study of that history of especially repairs of structure is not carried out, then you are going to collect a wrong information from site, and then you are going to interpret it wrongly. Always I will suggest that we should have a comparison, because all these NDT methods, they give you very good interpretation if you compare, say, two results. First, you should conduct the NDT where you have a defective member, where you have issue, and then straightway compare that member with other member where probably you have no issue. That could be that for one particular lot your cube strength is not passing, and for second lot your probably a cube strength is passing. Maybe you can take this as a comparison, and then compare the straightway results of these two tests. I have one example with me. I will share over here, because I know that sometimes people blindly believe on cube. It was the case of one national highway bridge. Pre-stress girders were casted, and they were about to be launched at site. And there were some around 8 or 10 girders, and out of that, for 2 girders, the cube results instead of 40, they were on lower side, and that's why the client, because naturally a government client, objected that for these 2 girders, the strength is on the low side, and we will not allow you to place this girder at site. Then contractor took this direction that simply depending upon the cube results, I will not discard these girders. Let us conduct NDT. And then we went over there, and then we recommended a detailed comprehensive test program for that particular site. We identified that what is the issue, what has happened, what are the cube results, how that has been casted, whether the girders they were pre-stressed, so whether the pre-stressing has been already carried out or not. Because if the pre-stressing is carried out, then the results are going to change. Because of the stress induced in that concrete, your ultrasonic and even for that matter, rebound also is going to give some different results. So we need to check all these conditions, whether all the girders they are pre-stressed or some of them are pre-stressed or not. And then after comparison, we told the client that don't tell us that which girders are now problematic. We will conduct test on all 10 girders. And we conducted test on all 10 girders, and when we compare simply the results among the girders, we said that these two girders, there seems to have problem. Then client that something is wrong. So these two girders, we are saying one girder is good and one girder is bad. And you are saying that both girders are having problem. And the one girder which is not showing a problem, you are saying that's good. So something is wrong. We said that this is a straightway comparison. So there is nothing that I am giving some interpretation. The facts are in front of you. So if the reading of entire girder, if they are on low side, definitely something is wrong with that. And then the cores were acted, and the core results, they exactly reflected that the girders which were shown on lower side by hammer and ultrasonic, exactly these two girders found out to be on lower side. So always I would recommend that we should compare a defective member with an accepted member. Then try to match or correlate the NDT test results with the site symptoms or manifestations. So we should collect information from site that whether really the surface is not good or the site concrete. I know that where the structures are very old, it may happen if the strength is less than say around say M5 or M8, then it is possible that even with a simple hand pressure, you can take out the corner piece of the beam of column. So try to correlate even with your physical judgments. Then try to identify where are the cracks, whether the cracks are shrinkage cracks or they are structural cracks, and why these structural cracks are appearing over there. So whether they are compression cracks, tension cracks, flexure cracks, torsion cracks. So we need to identify each and everything and then correlate with our ND test results. Again, carry out proper surface preparation. Regular calibration of instrument is very, very essential, very essential. A ultrasonic testing machine needs to be calibrated every day before you start your testing. Rebound hammer, it needs to be calibrated very frequently and maybe within a span of maybe 2 to 3 months. I know many labs or many colleges or institutes, they have rebound hammers with them, but they don't have a basic calibration anvil for calibrating rebound hammer. And they blindly use these rebound hammers for years and years together without calibrating. So if your rebound hammer is not calibrated within a frequency of, as I'm saying, maybe a span of 2 to 3 months, then your results are going to be totally wrong. Then collect sufficient data, already as I said, that which affect the site conditions. Then properly understand the principle of ND test being performed. Because this is very important. Sometimes it may be a case that that particular test is not suitable at that particular time. Maybe, suppose if you are taking an example of say Hubser potential test, and if your concrete is carbonated and maybe of the tube around say 40 to 50 mm, in such case your upsell potential test is not going to give you proper reliability. It's not going to give you a correct result. The results will be more negative, and then you may intend to declare that concrete that is going to have a corrosion. So it's very important that you collect all this information and you basically know what are the limitations of each and every test. And when I am saying that you should know, it's not the NDT consultant. That every person involved in this entire investigation process, the client, the architect, the structural consultant, the project management consultant, the contractor, whosoever they are involved in this process, they should be aware about these principles or limitations. Maybe a NDT consultant can help them and he can explain them that what are the limitations or what are the factors affecting. But all the concerned parties, they should be aware of this, because I know that many times most of the end users, they are totally unaware about this entire scientific process. And then they try to expect something very big from NDT, and they have something assumed in mind that this is going to be the ultimate results. And if that result do not match, then they start doubting NDT. It's not doubting NDT. We need to doubt the entire process of this, how we have formulated. If you have very less sample size, if you have selected a wrong member, suppose you are testing a beam and you are basically testing that beam to know a compressive strength, then you should know in a beam where the compression and where the tension is. You should select such a point where there is a compression member. I see very casually people select the point. कहाँ पे भी एक reading ले लेते हैं. Maybe hardly one reading is taken on the entire member, and then you land up in problem. As I said that we should combine always two or more NDT methods. The recommendations I would give is you should combine rebound hammer with ultrasonic pulse velocity. Rebound hammer plus ultrasonic plus core is the best combination. For corrosion mapping, you should combine half cell potential and resistivity. Again, a best combination is to combine half cell potential, resistivity, carbonation, sulfate and chloride test. This is the best combination you should go with for identifying a corrosion problem. If you are testing a pile, then you should combine a pile integrity plus ultrasonic plus core. I will explain here why we need to take ultrasonic for pile integrity testing. As I am saying that everyone should know how the every test it works. What is the basic principle on which it works? So for pile integrity, normally there is the input that either you should know the depth of pile. If the depth of pile is known, then you know the transmission speed. So based on that, the software will calculate the velocity of that concrete, and then that velocity is used as an input, and then based on that velocity, the entire integrity of that pile is mapped, and then the issues or locations, they are identified based on the velocity what we are given as an input. So there are 2-3 options available. First, the most reliable option is you should have the exact depth of pile known. If that depth is known, then you give that as an input and then calculate the reverse wave velocity. So that is the most reliable and correct method. But suppose if the piles are old, we don't know that what is the depth of pile, and in fact we want to find out that what is the depth of pile. So in such case, there are 2 options. One option normally, which is given or recommended by most of the pile integrity testing manufacturers, they give some charts of compressive strength versus ultrasonic. So in that case, you should know what is the strength of your concrete. And if strength of concrete is known, then referring to those charts given by the manufacturer, then you may assume that ultrasonic and then give that as an input to the pile integrity testing machine. But if you ask me, simply if the grade of concrete is specified in document, that doesn't mean that your site concrete is going to have same grade or same concrete. In fact, my experience for last 33 years tells me that invariably as concrete is having a lot of heterogeneity, batch to batch, there is a large variation, and even at site we have seen that the variation can be 1 or 2 grade plus minus. Many times I see that people again have some comments that suppose the concrete of M20 is used for a water tank, and if you are testing that water tank after say 15 years, and NDT results they indicate, if suppose NDT result that they give a value that, or even a core for that matter, if it gives a values of say M30, then people straightway challenge that how it's possible that when my contact document is saying that we have used M20 grade concrete, how come you are saying that this concrete is M30? It's not possible. But try to understand that particular structure is a water tank. So your concrete is continuously either under wet condition or is having a sufficient moisture. And that's why during the 15 years, your concrete is going to develop much higher strength what you are anticipating. Your 28 days strength is not the only reliable parameter. So even if you know that this is a M20 grade concrete, you should not assume that as a M20 concrete. So here what we recommend that we should use a ultrasonic pulse velocity test along with pile integrity test. We should open the top, say 1 or 1.5 meter of pile concrete and conduct a ultrasonic pulse velocity test at that point. And then this velocity should be used as an input for your pile integrity. Of course, when I'm making this statement, I know that even suppose a pile is having a depth of 10 meter and we are checking only top 1 meter. So here we are making an assumption that my 1 meter top concrete is same throughout the depth of concrete. And that's a very vital assumption. It may not be true, but there is no other way than to conduct this ultrasonic pulse velocity. Of course, again, when we have collected this ultrasonic pulse velocity conducted UPV on pile, the UPV conducted on pile when we are placing the probes on opposite surface, the velocity what we are getting over here is a P wave of a solid mass. And when we are going to use a pile integrity instrument, wherein the pulse is going to give you a velocity of a rod. So velocity of a rod and velocity of a solid mass, they are not same. Then you should be aware of all these mathematics and limitations, and then you should convert that ultrasonic P wave velocity into a rodded velocity, and then that should be given as a pile integrity velocity for pile integrity. And then in such case, you will get your pile integrity results more accurate. So that's why I'm saying that you must combine various tests together. And the best recommended practice for pile is pile integrity plus UPV plus core. Maybe even you can use pile integrity plus pile load test. That load test can be a physical static load test or it can be even a dynamic load test. And again, if you combine all four together, pile integrity plus UPV plus core plus pile dynamic test, then that's the best recommended method. Then if you are using radar, then maybe depending upon the purpose of radar which is being used, sometimes even you can combine a thermography. Suppose you are using a radar for finding out the leakages issue or seepages, then thermography, if you combine, then that's going to definitely give you a better result. If you are conducting maturity test, then I would recommend to combine pull-out test and core test, or even you can combine maturity plus pull-out plus core plus ultrasonic. That could be a very good combination. The selection of type of test. This is very important that we need to select a type of test. We need to take a right sampling, and this how many tests are to be conducted. That will depend on the type of structure, use of structure, its importance, size of structure, location of structure or that particular site. Suppose the site is located in Mumbai, which is a coastal area, then the test, some tests for corrosion mapping, they could be different. If the site is suppose located in Pune or Nagpur, which are very dry area, where I know that probably there is going to be a carbonation, so I would select some different test. Then sizes of individual members also we need to take into account. That what is the thickness of that particular member? So is it going to have a limitation on that? Suppose you are checking a foundation which is going to have a size of around, again I'll give an example of say windmill foundation, where they have sizes of around 10 to 15 meter diameters and thickness could be even 1.5 to 3 meters. So in such cases, even your ultrasonic is going to have limitation, because normally these ultrasonic machines, whatever available, most of them, they can scan up to around 8 to 10 meter depth. So if you have a foundation of 15 meter, then ultrasonic is not going to travel. Then maybe here you have to go with a semi-direct method. So type of test also you can decide based on the sizes. The number of members, how many numbers you have at site. Suppose there is a building of 1 lakh square feet and you have say 300-400 columns and say around 500 beams. So then we need to take a call that where is the problem. So whether the problem is a only localized problem or it's spread over entire area. For that, we need to identify what is the purpose of testing, then extent and type of problem, and what exactly we need to address. So everything needs to be jotted down before we decide the entire NDT program. Then sometimes accessibility of structure, it may pose a problem. Suppose you are testing a jetty or say piers of bridges. So most of the tests you can conduct only above the water surface. You cannot conduct the test below the water level. So accessibility may pose a problem. Suppose there is a chimney which is 45 or 50 meters high. Then how you are going to access that chimney at a height of 30 or 50 meters? It's practically going to be impossible because scaffolding you may erect for certain heights, or maybe especially in cases of even ISSE buildings, the 10-15 story structures, how you are going to access an external column or an external beam. So we need to identify all these issues before we start the NDT program. And then also, of course, we should know what is the exposure condition, whether that plant is located in a chemical area or whether that's a mechanical industry or whether, as I'm saying, whether it is exposed to any aggressive exposure condition. So all these data we should know beforehand. And then we select type of test, how many tests, and where they are to be conducted. Then that also includes the type of ND test being performed and number of ND tests being combined, factors which affect the test, applicability of test, sometimes even availability of NDT instruments. That you may want to have a test, as I'm saying, that you want to test a foundation of around say 15 meter, but no ND tool is available for testing such a depth. So maybe you have to identify that what are the issues, and the important issue is economy of an entire testing program. This we need to compare with the cost of proposed repair and rehabilitation. Unfortunately, it happens in India that NDT is given a very least priority, and hardly a fraction of amount is allocated to this entire NDT program, which is a very crux of your entire investigation. So very small amount is allocated, and then maybe hardly sometimes we get a call that a building is around say 30-40,000 square feet. Especially I'm giving example of all old society buildings where we are giving stability certificates. When we are giving stability certificates, I think NDT, it has to be a mandatory process. How simply on visual observations or your clinical observations, how we can declare that building as it's structurally safe and stable? Of course, there has to be an investigation of all the members. There are n number of issues with structural audit, but when you are going to give a structural stability, especially for all these society buildings, where it is mandatory to give stability certification, you need to have a very detailed, thorough investigation program. I know number of such cases where the societies or the buildings, they are around 10-15 buildings in entire complex, and the structural stability, when that inquiry is float, nowhere the test, which tests are to be carried out, that is written. How many tests are to be carried out, that is not written. And then there is a rat race amongst all this NDT consultant and structural consultant to get that tender. And simply they quote some very wrong figure, very low figure. And at site, hardly open 1 or 2 members in entire 10 or 12 buildings. I have seen many such cases, many such cases. And just simply to get that job, people tend to have a very smaller size of NDT program. And if that is going to happen, then you're going to land up in problem. And that's why the testing program should have some defined, it should have a weightage, and whatever the cost is incurred, that needs to be firstly decided among the client. The client needs to be convinced why these stages are important and how they are going to help ultimately the client. And suppose if the cost of your proposed repair and rehabilitation is going to be very high, and normally which is very high, compared to that, NDT cost is hardly any fraction. Is hardly any fraction, hardly 1 or 2% of your entire repair and rehabilitation cost. But still, I see that people are not ready to spend even this 1 or 2% on NDT. These are some of my recommendations that how many testing samples or how many tests we should conduct. So first we should know what is the reason for testing, why we are conducting, and then I'm recommending some minimum number of members that we should test. Suppose this is a routine testing as a quality control, I strongly recommend to use non-destructive testing as a quality control tool. When your structure is in progress, it is under construction, I strongly recommend to use this NDT as a quality control. Right from day one, when you're casting your cubes, even right from that stage, you should start collecting data of your NDT. And then that becomes perpetual data available with you. So if you have emulated a concrete of your site right at the casting stage, then even at later age, say 5 years, 10 years afterwards, suppose we find something problematic, then we have a data available with us. Straightway we can compare that data and use that as a correlation chart for your problem at that time. So I strongly recommend that each and every project we should have 5 to 15% of NDT test as a mandatory test. If the project is too big, then maybe 5%. If the project is small, then maybe we can have 15%. If cube strength is not passing, then maybe we go with 25-50%. If you want to assess the overall stability of old structure, as I'm giving an example of say cooperative housing societies, then in initial stage, at least we should have 15 to 25% of sampling. As against, as I'm saying that people test hardly, not even 0.1%. Out of say 1,000 columns, they test hardly 1 column or 2 columns. It's not going to help you. You should have 15 to 25%. Wherever there is a specific problem or where you have some capacity issue of particular area or specific member, then 100% of that member or that area needs to be checked. If it is a fire or blast damage assessment, then we need to check 50 to 100%. If it's a corrosion damage or earthquake assessment, 15 to 25. Pile integrity testing, I would strongly recommend we should test 100% piles with pile integrity, because we know that whatever pile concrete goes in pile, it's black. We don't know anything about what has happened inside the ground. And based on 100% pile integrity testing, then you can take a call for pile load testing, that is static or dynamic, and that can be 10 to 25%. If you are assessing the condition of heritage structures, this is very vital. So there I would recommend that you should test 50 to 100%. If you are doing a forensic engineering, that something has gone wrong, a structure has collapsed, and then you need to do a root cause analysis. So in such cases also you need to do the testing of 25 to 100% of structures. Then how many tests per member or per length we should use? So there I am recommending for rebound and ultrasonic test, at least 1 point per 1 meter or 1.5 meter of length should be used. Same, if it is a half cell potential or resistivity test, I would recommend 1 point per half a meter to 1 meter. Or if it is a slab, then for say 100 square feet area, 10 square meter, we should use 3 points at least. If you are testing core, then I would recommend minimum as 6 or 10% of the total points what we are used with rebound and ultrasonic. So suppose you are tested 100 points with ultrasonic, then you should use extract at least 10 cores. If you have extracted, say, 1,000, if you have tested 1,000 points with UPV rebound hammer, then you should extract at least 100 cores. There are codes available, especially the European code 13791. The code is 13791. That code, it talks of assessment of in situ compressive strength in structure. I would recommend everyone that this is a very important code, and you should recommend that how many samples you should have. Of course, this code talks of sampling for core. This code recommends, depending upon the diameter of your core, it gives certain values. I'll come back to that. The minimum value recommended is 10. They say minimum 8, preferably 10. And for a diameter where it is more than 75 mm. If the diameter is less than 75 mm, then they have given some factors by which we need to multiply these samples. So pile integrity testing, if diameter is up to 300 mm, 1 point. If it is more than that, then up to 600, maybe 3 to 5 points. Then testing of specific assessment. So first I had given a general assessment. Now suppose you want to assess a specific particular member or specific area where you know that there is an issue and that we need to identify in depth, or maybe you're using that as a forensic engineering tool, then you should have some further closer spacing. Typical scenario is where your NDT results, they do not give site observations. Because as I said in my earlier first discussion, that there are some cases where people report that your NDT results, they are not matching site conditions. So first case, typical what we get is NDT report indicates a very lower strength concrete, but there are no site observations such as cracks, crushing of concrete, or deflections of members. This is a very typical situation. In older structure where the concrete used to be M15, or even for that matter, the new structures which are very high strength, we have n number of cases with us that the strength at site is observed to be as low as 1/3 to half of the required. And when such an NDT result is produced, then a doubt is raised that something is wrong with NDT. How this is possible that the strength is 1/3 and still my site concrete or that member is not having any crack? By the time if it is 1/3, then it should have crumbled, it should have crashed, it should have collapsed. This is a very common comment which is made at site. I'm going to come, let me check whether I get sufficient time. I'll show you one example. I've prepared one table over here. That suppose if we get a 50% reduction in strength, or suppose we get a 1/3 strength at site, then what is really going to happen with your column or beam or a slab? So is it really going to crack or crash or crumble or fail? So I have prepared one table. So I'll go to that one. Now coming to the half cell potential test or resistivity test, sometimes it may happen that these tests, they indicate a very high possibility or rate of corrosion. But at site, suppose if you open the steel, we find that there is no corrosion, or the corrosion is hardly or very small amount of corrosion, or vice versa. That my test results, they are not indicating any corrosion, but when I open the steel, then there is a corrosion seen over there. So this is another situation. Then a very common situation is depth of carbonation has crossed the cover concrete, but there is no corrosion. Many times, especially in dry areas like Pune or Nagpur or say other areas which are more or less dry compared to coastal regions, there we notice that the depth of carbonation, it crosses very high amount. It crosses around say 25 to 50, 70, 100 mm. And if your cover concrete for slab and beam, if it is say 25 or 40 mm, then your entire cover concrete has carbonated. But once we open the steel, we notice that there is no corrosion. So let me tell here that again, as I'm repeatedly saying, that before we carry out all these tests, each and every person should know the basic of this all testing. He should know the basics of concrete technology. He should know the basic of machines, how they work, how they are formulated. You should know basics of your corrosion. You should know what are the repair and rehabilitation systems which are available in market. You should have entire thorough knowledge of all these things, and then we should try to correlate this. It's not necessary that the carbonation depth has passed your covered concrete. It is not necessary that steel has to corrode. Yes, carbonation is indicating that my pH of concrete, which is normally at around say 13 to 13.5, it has dropped to somewhere around 8 to 9. So concrete has lost the passivity along the reinforcement. So this gives a good probable condition to have a corrosion. But that doesn't mean that carbonation triggers a corrosion. No, corrosion is not triggered by a carbonation. Carbonation is a favorable factor which will increase the corrosion. To have a corrosion, first you should have a moisture and oxygen. If you have moisture and oxygen, then and then only your corrosion is going to trigger. And in such case, if the concrete is already carbonated, then yes, definitely the corrosion is going to be at much faster rate and at much higher scale. So it's not necessary that concrete is carbonated, then the steel has to be corroded. Or reverse way, say take a case of Mumbai, where in first few years, the concrete may not be carbonated, it may not have touched the reinforcement, but still you see that there is a lot of corrosion of reinforcement. So I'm saying that carbonation is not going to trigger a corrosion, but it is a favorable condition for corrosion. So we should know all these intricacies, then we can interpret the NDT results more correctly. Sometimes we see that there is a very large variation in the NDT results. Maybe, suppose you are having a structure of around say 10,000 square feet and you are tested say around 100 columns, then you get a variation in your ultrasonic as low as somewhere say 2 kilometers per second to as high as 4 kilometers per second. Or even in a one member itself, it may happen that at top of column, you are getting a velocity of say 2.5 and at bottom of your column, you are getting a velocity of say 3.2. So there could be such cases that even within a member itself also, there could be a substantial change in the test observation. Yeah, sir. So when we get such large variation in strength, not only with the rebound and ultrasonic or half cell, even many times you may see that when you have extracted the core samples, there could be a large variation in the strength. Even if you have extracted core samples, suppose in a beam you have extracted at two different locations, the strength could be different. And then we should try to again understand that this is nothing wrong with NDT, but this indicates a inferior placement of your concrete. My batching is not proper. My batch to batch concrete, there is quite a large variation. And this is very, very common, because when we start concreting in morning, normally you have good quality control. And this is a very well known fact that when we start the concreting, the first batch concrete is made exactly as per mixed design, because that from that concrete you cast your cubes. So I think we are cheating ourselves. खाली concrete cube भरने के लिए एक अलग सी बैच बनाई जाती है, and that is the ground reality at site. Go to any site, 95% of the sites in the morning there is a separate spatial batch which is casted simply for casting the cubes. And after that cubes are casted with that special batch, then the real sambar concrete, it starts at site. And then no correction is applied for your moisture absorption, because if there is a temperature change in afternoon, there is going to be a loss of moisture, then you need to have a correction for that. You need to add some water. As the concrete goes in the evening or night, then there is going to be available that you need to remove. All these corrections are required to be done at site, but hardly any site I see that these corrections are carried out. Then how you can expect that my concrete is going to have the same strength throughout the member or entire all the site area? This is not totally possible, and this is what I'm talking, a heterogeneity of that concrete. Then there could be some issues even with the testing procedure itself. So we need to identify that why these results, they do not match. So first I am saying that there are issues with some site. Now I am trying to identify that what could be the issues. So there could be some issues even the NDT testing procedure. Suppose incorrect selection of NDT test, as I given already example, that a use of standalone rebound hammer test is recommended on large foundation. Remember, rebound hammer, if there is a void or total cavity inside a foundation just hardly at a depth of say 50 mm, rebound hammer is not going to identify or detect such major flaws. So you should use a correct method. Incorrect surface preparation, already I have discussed this, that we need to open a plaster. We should not never conduct a test on a plastered surface. But as the tender was got with a very small amount, or it was on say lowest basis, then I see that NDT consultant, they don't even remove the plaster. They say कि पैसा ही नहीं मिल रहा है, इसने plaster निकालने का, पैसा कहाँ ज्यादा डालने का. So this is how the things go wrong. Then incorrect test method, especially I will give you example for slab testing. If you are testing a slab with ultrasonic pulse velocity, you have to use a direct method for probing. I know for direct method of probing, there are going to be limitations, because from bottom, you need to remove the plaster. If it is a regular floor, then you need to remove a tiling, or if it is a roof, then you need to remove a waterproofing at test location area. Yes, but that has to be done. If that is the correct method, then you have to do that. This is very important. I see many times, most of the cases, people go with indirect probing for slabs. They will place the probes from bottom of slab, and then they will carry out the ND test. Remember, direct probing is only reliable because the velocities or that speed or that strength of pulse is very strong and reliable only and only in direct probing. Then somewhat lower with semi-direct, and indirect probing is the least accurate method. Indirect probing is to be used only and only wherever you want to measure the depth of crack, or you have sufficient core samples available with you, which you are going to extract at these indirect locations. Maybe some cases of say cement silos or say retaining walls wherein other face may not be easily accessible. In such cases, maybe indirect method be thought. But remember, even indirect method is going to pass only from surface, and that too only from a surface concrete of around again 25 to 50 mm. And indirect concrete is not going to give you at all any indication of your inner concrete. And I see very commonly people use slab simply because they want to save cost, or because they have the same rate which they have quoted for the beams and columns. I think somewhere we are going wrong. Every time we are going with some economy or some wrong practices. So we need to stop this all wrong practices. We have to have a slab tested from both the sides. If faced any problem, the client comments that no, he doesn't want to remove a tile or waterproofing. If you try to convince a client and if you try to give a technical justification, then yes, client is going to allow you for removal of tile or waterproofing. So never use indirect method. Even I have seen that people use indirect method for slab and then they don't detect the reinforcement. If the probes are going to be placed over the reinforcement and if the probes are parallel to the reinforcement, then your pulse is going to pass through the reinforcement and not through concrete. And then you're going to get a very high velocity. And the result is going to be a totally false result. Then coming to next point, incorrect selection of test location. As I said that we need to identify the correct position of test location. Already I told you that suppose I am interested in compression, then I should select a compression zone of my member. Why I should test a tension zone, which is not, I'm not going to utilize that in my design. If I'm neglecting tension zone of my, especially in say flexural members, beams and slab, then why should I test my flexural member? Exactly coming back to slab. When I know that my top portion is in compression, bottom is in tension, and you're testing with indirect UPV probing of that slab in bottom, you're doing wrong selection of testing. The concrete should be tested through and through. Then use of incorrect procedure for test. For example, if you're doing ultrasonic pulse velocity, it's very important that your probes, if you're testing them in direct probing method, then they should be placed on exactly opposite sides. Then most of the time I see that people assume the dimension of that members. That is for column slabs or beams. And for slab, invariably it is assumed. Because it's very difficult unless until you drill a hole and physically measure the thickness of slab. The measurement of slab is very difficult, but that's very important. You have to measure the exact width of your member. Don't simply go with the drawing and assume whether drawing is showing that 230. Don't write in your reading sheet that it's 230. Physically measured, because there is a good possibility that that particular location, the size of your member is going to be different. And the best example, if it is going to be a timber shuttering, when you order a 9-inch plank, you never get 9-inch plank. You get 8.5-inch plank in market. So it's very clear that your measurement is going to be wrong by around say 10 to 20 mm. How you assume the width of member? You need to measure. Then incorrect understanding of factors affecting the test. Ultrasonic example, or even for half cell. Ultrasonic test is affected by the temperature of concrete. When you measure the ultrasonic, you take the ultrasonic measurement, at that time, it is mandatory that you should measure a temperature of concrete. At how many locations, at how many sites people measure the temperature of concrete? And how many places they apply the correction for this UPV test? Similarly, for half cell potential, the temperature of that cell, that needs to be measured. Because if the temperature of that cell is different, and it is quite going to happen, because in morning the temperature of cell could be different, in the afternoon if you are working outside in the field, so because of the continuous exposure to sun, the temperature of your half cell is going to change. You need to take the temperature of half cell. So there are such n number of factors which affect the test. So the testing agency, he should be aware of these all factors and they should collect all these data. Then incorrect data, collection of incorrect data, information collected from site or client is not given correctly, and insufficient test samples. I know the time we are already touching because the scheduled time was 4 to 5:30. I will take 1 or 2 slides and maybe I will stop afterwards. So there could be some issues with the non-destructive testing procedures, that the instruments are non-calibrated, faulty instruments are being used, the test person, he is not experienced person, lack of understanding of testing principles, not combining associate or supporting tests. Again, a very important example. Suppose you are conducting a rebound hammer test wherein a carbonation which affects the rebound hammer substantially. If the concrete is carbonated, then your rebound numbers can be as high as 30 to 40, 45% high. So in such case, you need to conduct a carbonation test along with rebound hammer. I think for rebound hammer, carbonation test is a mandatory associated supporting test. You should not conduct rebound hammer test without carbonation test. The results will be totally wrong, totally wrong. Then variation in test locations when combined with ND test. Sometimes, actually, theoretically how it should be done, a systematic NDT program. First, you should carry out the indirect methods like rebound hammer and ultrasonic at specific location. Maybe you conduct a big sample size on say 100. Then find out the highest and lowest value and distribute the number of cores, say 10% cores, in these distributed range of ultrasonic. And now when you're going to extract that core sample, it has to be extracted exactly at same location. It's very important. And worst, I'm very sorry to mention over here, but I know cases where tests are even not performed. Fake results are produced by the NDT consultants. This is very shameless. It's very serious issue, but unfortunately this is a bitter fact. And day by day I see that this is increasing. And again, the reason, because I have quoted on very much low side, so that's why I'm not able to perform the test. It's very obvious. You pay peanuts, you will get monkeys. Okay, I think time is very short. Okay, I'll try to cover up one or two and let us see how we can conclude. So issues with the incorrect assessment and interpretation. Blind use of strength correlation graphs. Already I have said that use of graph for rebound hammer. Not using or applying various correction factors. It's very important. For different site conditions, materials, environmental conditions, such as temperature, moisture, stresses, carbonation, cover depth, n number of factors here required to collect from site. That NDT laboratory should have developed a sufficient correlation charts or correction factors for all these temperatures, moisture, stresses, carbonation, or so many. For that matter, rebound hammer, the rebound hammer calibration for OPC cement and rebound hammer calibration for blended cement, it's not going to be same. You cannot have a single graph. You have to have different graphs. If you're using a ultrasonic, the stress factor it's very important. You should have a stress factor available with you. You should know what is the stress factor and how it's going to affect. The stress factor affects a velocity by a tune of around 15 to 40-45%. The velocity is reduced because of simply stresses. Then you should know that how to identify these stresses and apply correction stress factor. Then lack of understanding of entire complexity of NDT program. Lack of understanding of structural behavior and concrete technology. There are issues that we don't know exactly what is the concrete. Sometimes I see that there are issues with the interpretation on the client side, or if it is a structural engineer or agency who has formulated that program. So there could be problem even at these locations also, that not properly identifying the proper test. The agency who has decided this program, he has not identified the correct test. He has not done the correct root cause analysis, not correctly identified the type of test to be performed, how many testing is to be performed. Most of the time, there is an insufficient test sampling. In most of the cases, NDT program is decided very casually, without giving in-depth about NDT, why it is proposed, how it should be done. Then lack of understanding of complexity of entire NDT program, lack of understanding of structural behaviors, site conditions, and concrete technology. Repeatedly, I am saying concrete technology because I see that people take concrete very casually and they don't know what exactly is the strength. When I'm talking a characteristic strength, when I'm talking in situ strength, what is the difference between in situ strength and characteristic strength? So there are n number of issues we should have. Then lack of knowledge about correct ways of conducting tests. I will skip some of this and then I will go to one or two slides and then I will stop. This paper is also available on my website. You can go with this because actually this is a very vast presentation. I am trying to cover within a span of 1.5 hours. It requires normally more than 4 to 5 hours. So simply I am skipping these slides. You can refer on my site conditions on my website where you will get all these details available. Now for ultrasonic, a code has been revised. Earlier, the NDT methods were available under the code 13311 part 1 and part 2. Now, out of that, part 1 code is now totally scrapped. And now, IS code committee is coming out with a different code. 516 is now being totally revised. And under 516, part 5 is now going to cover all the NDT tests. Out of that, section 1 is now declared for ultrasonic. Rebound hammer, that code is already, draft code is already been published, and anytime you may expect even that code. Then core is already covered in 516 section 4. Half cell potential test is also now going to get covered under this section in part 5, 5 and 6. So please refer to the correct parts. Some recommendations I am for test wise I am already highlighting over here. I am not going in detail. Now straightway I will shift to these are some of the definitions I think we should be familiar. So what is a standard cube strength? What is a core strength? What is in situ compressive strength or equivalent cube strength? What is a potential cube strength? For that I have referred over here BS 6089. You can refer that code. Actually 6089 is very similar to that of European code 13791. Maybe you can note down some of the codes which are very important. Already I have given two. First is EN 13791. Second is BS 6089. Then ACI 214R. ACI 214.4R. R stands for revision. I am not telling you the latest years, that you can check on website. Then ACI 228.1, ACI 228.2, ACI 437. So these are some of the very important codes which you should refer when we draft this entire NDT plan. I will show you this one slide and then I will stop. This is what I was talking in the beginning. That this I have given an example of a column which is 200 by 530 mm with 8 bars of 12 mm dia and Fe415. Now first two cases is a case where my design grade of concrete is M30. For that, suppose axial load I am having 850, mx I am having 40 kilonewton, my 15, and there I am getting a stress ratio of say 0.9. Similar same column with same grade, but now load is slightly less because my my I have increased my, so 650 kilonewtons, 10 is mx. There is a mistake, it's not 250, it has to be 25. So it's 25 kilonewton meter, then stress ratio is 0.98. Now suppose if we find that instead of M20, now at site the concrete is M20 instead of 30. So the reduction in strength of concrete is substantial. But actual reduction, if you see in your load carrying capacity, when it is getting reduced from 30 to 20, it is only 30%. It is not more than that. Even if the concrete has reduced to say 1/3, that is 30 concrete, it has dropped down to M10, still your overall capacity reduction is not 2/3. It's not 66%, but it is 50% only. Maybe column could be a case where a reduction in concrete strength will give you some reduction in overall capacity. But if you take the case of say slab, 4 by 4.5 meter span, 150 mm thick, if it is M30 grade, if it has reduced to 20, then hardly there is going to be reduction of 3%. If it has dropped down from 30 to 10, still there will be reduction hardly of only 10% in your load. It's not that it's going to be 1/3. And that's why I said that sometimes when people make loose comments, when concrete has reduced from 30 to 10, by the time it should have collapsed. It should have given a cracks. No, it is not going to give you. Especially for flexural member, it's not going to give you. Take an example of beam. Suppose it is 230 by 450. Then grade of concrete, suppose earlier it was 30. Now the moment resisted, it could be say 60. For that AST required is say 445. So for same 445, even if it drops down to M10, the overall reduction in your moment is from 60 to 51. It's only 5% and it's not 2/3 reduction. So this is a point I think we should, everyone should note. Okay, so I'm stopping over here. Those who are interested, they can note down. This is my contact details. Maybe later on, if you have any questions, you can straightway direct it to me if we are not able to answer these questions in totality today. Okay, hand it over to Mr. Mahajan, sir.
Thank you, sir. Thank you, Ranade, sir, for your detailed lecture on NDT. There are many points on which we have emphasis on, and there are many points, finer points, for which one should take care at site, either by the NDT companies or even by the site engineers, so that the results are fruitful and results are better for the structure. Now, there are a lot of questions people have raised. Okay. Due to the paucity of time, I think we'll take only 4 or 5 questions.
Okay,
so I will read one by one question and then you can answer accordingly, sir.
Okay.
So the first question is, what is the proficiency of each NDT lab to develop the graph for rebound hammer test?
Can you repeat again?
What is the proficiency of each NDT lab to develop graph for rebound hammer test?
Okay, I've not understood the question correctly, but I'll try to answer it. As I was repeatedly saying that every lab should develop the correlation graphs. So it is not only for strength. If I'm taking example of say rebound hammer, then every lab needs to establish a correlation of the rebound hammer versus strength. For that, you have to have sufficient samples available with you. Start with at least say around 200 to 300 cubes, but don't stop with that, because that is not going to give a reliable results. We are testing till date, even after now practicing for more than 25 years, still we test cubes in our lab with rebound hammer, ultrasonic and core. And till that, by the time we are tested now more than around 80,000 cubes, and still I am not happy with the correlation charts. So from that you can understand how much is the complexity. So you need to correlate the cubes with the rebound hammer or ultrasonic. So before testing, you have to take the reading. When you are placing that cube in testing machine, at that point you have to take the ultrasonic or rebound hammer and then crush it and then correlate it. But then you have to have different graphs for different ages, different types of cement, different types of aggregates, different types of say other parameters which are varying, because correlation chart for especially for ultrasonic, it won't be same which you are drawn for M20. Same correlation chart is not going to be valid for M40. So you have to have different n number of correlation charts. And again, not only correlation chart, your rebound number is going to change with the moisture condition. Same is with ultrasonic also. Ultrasonic is going to change with moisture. So there are similar number of factors which affect these parameters. You should identify and then conduct R&D on that. And for that, I would suggest that you will require, if you have to have at least some preliminary level stable equation, then if you ask me, the minimum number could be around say 2000 to 3000 cubes. Below that, I don't think that it's going to be a reliable graph.
Yeah, there were two questions on similar line, correlation of cube strength and the NDT strength. So we have already answered that. The next question is, when we are testing compressive strength of concrete by core, how does compression and tension zone plays a role?
Okay, it's not the core, but I am talking from where you are extracting that core. Now suppose in a beam, you have extracted a core at a center from the top portion, that is above neutral axis, which is going to be under compression. And if that core you are going to test, in any case, core you are going to crush it for compression. So there is no point that we are talking of tension in core. Core is going to be tested for compression. But from where you are extracting that core, I think if you are interested in knowing the compressive strength of concrete, then you should extract a sample where the compression is present in that member. So if you are extracting a sample from a bottom, say below the neutral axis, where there is going to be a tension, that is not going to give you a correct answer, because I am not at all interested in that zone. So that's why I am saying, even ultrasonic also, if you want to conduct at a compression zone. If it is a column, no issue. Entire section is under compression. You can conduct anywhere. So it has not to relate with the core, but it has to relate with the member where there is a compression or tension.
Yes, sir. Next question is an interesting question. It mentions core test is a better option in regards NDT to know the strength. But what about the heritage structure or old structure? How to take the course in that?
Okay, if you are talking of heritage structures, if it is RCC, then still there is no issue if it is concrete. But if you are talking of say timber structure, then definitely core is not going to be an option at all. But for timber structure, yes, there are different methods which we are implementing for various heritage structures. For timber, you can use different methods altogether. Maybe you can use tapping survey, rebound hammer, ultrasonic. We have the micro drill resistance.